lecture we solve number of numericals based on equivalent resistance. Let question number 1. Find the equivalent resistance between the terminals A and B, and the equivalent resistance between the terminals A and B. This is my question. A, B, here 2 ohm given, 3 ohm, 7 ohm, 4 ohm. Then how to determine the equivalent resistance? First, what we will do? First method is accordingly current behavior. We can tell resistances are connected series or parallel. If same current is flowing through the resistance, then we can tell resistances are connected in series. If current is divided, then resistances are connected in parallel. Now we solve this numerical. This is a very easy questions. In solution, again we redraw this circuit. This is the circuit. A and B, here 2 ohm, 3 ohm, 7 ohm, 4 ohm. Now we start. That means we assume a voltage source is connected between the terminals A and B. When we calculate the equivalent resistance. Here I current is started. Let I current at this point current is divided. I1 is flowing here, I2 is flowing here. Because we have two paths for current. Same path here, I1 is flowing. Here I1. Then total I current ends at the B terminals. I current started from the terminals A and same I current ends with B terminal. That means what we consider a voltage source is connected between the terminals A and B. Then how to calculate the equivalent resistance? We just move in opposite direction. That means if we calculate the equivalent resistance between A and B, we just move in opposite direction. We reduce in opposite direction so that we get easily the equivalent resistance. That means since in 3 ohm and 4 ohm I1 current is flowing, both are connected in series, same current. That means in series connection the equivalent resistance is algebraic sum. Here what we write implies that we get this type of circuit now. This is 2 ohm, here 7 ohm, this 3 plus 4, that is 7 ohm, and here we get A and B. This is RAB. Here we write 3 ohm and 4 ohm are connected in series, hence R equivalent is equal to, we can write 3 plus 4 equal to 7 ohm. After that what we will do? We will move in opposite direction. This 7 ohm and 7 ohm connected in parallel and 2 ohm connected in series now. If we reduce this 7 ohm and 7 ohm connected in parallel, this is 2 ohm. What is the equivalent resistance then? 7 ohm and 7 ohm, that is equal to, we can write 7 by 2 ohm. This is A and B. Here we can write 7 ohm parallel with 7 ohm. What is the procedure? How to calculate the equivalent resistance? We can apply 1 by R equivalent is equal to 1 by 7 plus 1 by 7, or we can apply, since two resistances are connected in parallel, R equivalent is equal to, we can write product by sum 7 into 7 divided by 7 plus 7, or we can apply R equivalent is equal to, since resistances having same values and connected in parallel, what is the formula? Resistance value divided by number of resistances. Condition, what is the condition? Both are same values. Same values means what is the resistance value? 7 and number of resistors 2, 7 by 2 ohm. Any method we can apply so that we can easily calculate the equivalent resistance. Now this 2 ohm and 7 by 2 ohm are connected in series. I current if started, same I current ends with the B terminal. Now we get R equivalent is equal to 2 plus 7 by 2, that is equal to how much? We get 5.5. This is my answer. First one, very easy problem. Then now we solve another problem. Question number 2. Find RAB. This is the question. We calculate the RAB. A and B. Here 1 ohm available. 1 ohm, 1 ohm, 1 ohm, 1 ohm. All values 1 ohm. Then how we calculate the equivalent resistance between A and B? A means a voltage source is connected between the terminals A, and a voltage source is connected between terminal A and B. What we will do, if we will find this type of question, here there is a confusion. We apply the current methods, means same current is flowing, means resistances are connected in series. If current is divided, means resistances are connected in parallel. Before solving this problem, I will explain about some concept, that is circuit. Circuit means the path followed by the electric current, the path followed by the electric current is called as circuit. Is called as circuit. That means what we understand, circuit is a closed path. Circuit is a closed path. This is a circuit. One resistance is present here. We have a voltage source, positive, negative, I current is flowing, and same I current ends with the negative terminals. This is called as circuit. Then if we remove the resistance R, we get open circuit. If we remove the resistance R, we get open circuit here. This is V, positive, negative. This is the terminals. In open circuit, what happens? Let this terminal A means, since we have no circuit elements, this is also a terminal. This terminal B means this terminal also B. There is no circuit elements. What is circuit elements? This is a resistance R. A and B, it consists of two terminals. Every time I told this concept, a line is represented by a single point. Okay. Then here in open circuit case, what happens? What about the current? Since it is open circuited, no current is flowing. Current always flowing through a closed path. That means here I equal to 0. Open circuit means what is the voltage? Voltage across A and B, B. Obviously voltage across A and B also V. V is equal to V. What about the resistance? R is equal to V by I. That is equal to V divided by 0. We get infinite. What we get finally in open circuit, current is 0, voltage is maximum and resistance is infinite. Then another concept, short circuit. If we short circuit the above resistance, what we get? We get this type of circuit now. Now we short circuit this resistance, this part. Here voltage V. I current is flowing. Since it is a closed path, I current is flowing. But here voltage is equal to how much? In short circuit, voltage is equal to 0. Current is equal to I maximum. And resistance is equal to V by I. That is equal to 0 by I. That is equal to 0. Means in short circuit, current is maximum, resistance is 0. And voltage also 0. Now we solve the above problems. Solution. Here we solve now this problem. Here A and B, 1 ohm, 1 ohm, 1 ohm, 1 ohm, 1 ohm, all values 1 ohm. Now I current is started from the terminals A, let at this point current is divided, let here I1 is flowing, here I2 is flowing. Then at this terminal I1, no current is flowing in this resistance. Since it is a open circuit path, no current is flowing. No current is flowing. That means this, since it is a open circuit, now I1 current is flowing in this resistance. Here I2, here also no current is flowing due to open circuit. No current is flowing due to open circuit. Due to open circuit. Then same I2 current is flowing here. Here I1 and I2, same I current ends with the B terminals. Now what we get? This 1 ohm and 1 ohm, this 1 ohm and this 1 ohm connected in series, and this 1 ohm and this 1 ohm connected in series, because same current is flowing. What we get? We get this type of circuit now. This is 1 ohm. Since these two are connected in series, what is the equivalent resistance? 2 ohm. Here also 2 ohm. 1 plus 1, 2 ohm. And here 1 ohm is added. A and B. Now this 2 and 2 connected in parallel. Then what is the equivalent resistance? 2 by 2 equal to 1. Directly, there is no need to apply the conventional method. Resistance value divided by number of resistors, that is equal to 1 ohm. Here also 1. Here we can write this is terminal A, this is terminal B. Here we write 2 parallel 2. Then R equivalent is equal to resistance value divided by number of resistors, that is equal to 1 ohm. Finally, what we get? All are connected in series. RAB equal to 3 ohm. This is my answer. In this way, we can solve this problem. Next problem, question number 3. Find RAP. This is my question. 1 ohm, 1 ohm, 1 ohm, A terminal, B terminal. In this problem, if we apply the current methods, means if current remains same, resistances are connected in series. If current is divided, resistances are connected in parallel. If we apply this concept, then we have a confusion. If we will face the confusion, what we will do? We will go for the point methods. That means here we apply the point methods. Point method means a single line is represented by a single point. A single line is represented by a single point. This is a resistance. It consists of two terminals A and B. If I draw a line, means it represents a single point. That means I will solve this problem now. In solution, we can redraw this circuit again. This is 1 ohm, 1 ohm, 1 ohm. A terminal, B terminal. That means here there is no circuit elements, means this terminal is A, this terminal also A. Here no circuit elements, means this is B, means this terminal also B. Now we just rearrange the circuit. Let this is A point, this is B point. A point, B point, A to B 1 ohm, B to A 1 ohm, A to B 1 ohm. Then all three resistances are connected in parallel. Then what is the equivalent resistance? Very simple. R equivalent is equal to, since all are having same values, what is the formula? Resistance value divided by number of resistances divided by 3. 1 by 3 ohm. My answer. All are connected in parallel. 1 parallel 1 parallel 1. In this way we can solve the numericals. This is the point method. If current method fails, we will go for the point method. Then another problem we will solve now. Next problem, I think this is question number 4. Find RAB. A point, this is B point. Resistance value given 2 ohm, 3 ohm, 4 ohm, 5 ohm. In this question, how will solve? If we apply the current methods, then we have a confusion. Directly we will go the second step, that is point method. Again we redraw this circuit in the solution. The original circuit, this is the terminal A, this is the terminal B. Here 2 ohm is available, 3 ohm, 4 ohm, 5 ohm. If we apply the current methods, then fails. We have a confusion. Directly we will go for the point method. Point method means a single line can be represented as a single point. Let this is point number C. Also this point also C. Now we rearrange the circuit. If we rearrange the circuit, let this is point A, this is point B, this is point C. This terminal A means this terminal also A. This terminal B means this terminal is B. A to C 2 ohm. A to C is available 2 ohm. B to C 5 ohm. A to C 4 ohm. And B to C how much? 3 ohm. B to C 3 ohm. That means this 4 ohm and 2 ohm are connected in parallel. This 3 ohm and 5 ohm are connected in parallel. Total connected series. Then how we determine the equivalent resistance? Now R equivalent is equal to RAB is equal to, since two resistances are connected in parallel, what we write? If two resistances are connected in parallel, R1 parallel with R2, what is the equivalent resistance? Product divided by sum. Product divided by sum. That means we can write R1 R2 divided by R1 plus R2. Here what we write? RAB is equal to 4 and 2 connected in parallel means 4 into 2 divided by 4 plus 2, and connected in series means plus 5 and 3 connected in parallel means 5 into 3 divided by 5 plus 3. What is the value? That is equal to 3.2. This is my answer. In this way we will solve the numericals. Next question. Question number 5. Question number 5. Find RAB. A and B, all values are 1 ohm, 1 ohm, 1 ohm, 1 ohm. Then I will solve. Again, if we apply the current methods, current method means same current series, current divided parallel. We have a confusion. We will go for the point methods. Now we write the solution. We write the solution here. Same circuit, again we will read. A and B, all resistances 1 ohm, all are 1 ohm. Then let this point is C and this point is D. We just rearrange the circuit. A, B, C, D. A to C 1 ohm, A to C 1 ohm, C to D 1 ohm, D to B 1 ohm, then A to D 1 ohm and C to B 1 ohm. We just connect accordingly the name. In this problem, how will solve? If we get this type of problem, what we will do? We will apply the Wheaton bridge principle. This is the third method. Wheaton bridge principle. We discuss here first. What is the Wheaton bridge principle? Let this is figure number 1. Figure number 2. This is figure 1. Figure 1. Wheatstone bridge principle. Let we have the bridge. Let this is P, this is Q, this is R and S, and this is the X resistance. If what is the Wheatstone bridge? If P into Q equal to R into S, then the bridge is balanced. Then the bridge is balanced. Then the bridge is balanced and no current is flowing in X ohm resistance, and no current is flowing in X ohm resistance. That means it behaves as open circuit. That means it behaves as open circuit. In figure 2, what we get? In figure 2, 1 into 1 equal to, we can write in figure 2, we can write SC into BD, equal to BC into AD. That means we can write implies 1 into 1 equal to 1 into 1. Hence, the bridge is balanced. We can write hence the bridge is balanced and no current is flowing in CD branch. That means CD branch behaves as open circuit. Now we redraw the circuit. If CD branch behaves as open circuit means we just remove this CD branch. We just remove this 1 ohm resistance. We get this type of circuit. We get now this type of circuit. A, B, C, D, all values are 1 ohm, 1 ohm, 1 ohm, 1 ohm. We calculate the equivalent resistance between A and B. That means here current I1 is flowing. Here also same current I1 is flowing. Here I2 is flowing. Here I2 is flowing. That means what we get? This resistance and this resistance connected in series. This 1 ohm and 1 ohm connected in series. Same current is flowing, total connected in parallel. Then what we get? 1 plus 1 implies that we get this type of circuit. 1 plus 1, 2 ohm. 1 plus 1, 2 ohm. This is A and B. Here we write 1 ohm and 1 ohm are connected in series. Then this 2 and 2 connected in parallel. What is RAB? RAB is equal to how much? RAB is equal to resistance value 2 by 2 equal to 1. This is very easy problem. This is the third step. First one is current behavior. Second one is point method. Third one is Wheatstone bridge. If the bridge is not balanced, then it is very difficult to solve the numericals. That means we will apply the star delta conversion. Another problem I will solve now. Another problem, that is question number 6. Find RAB. This is my question. This is the question. We calculate the equivalent resistance between A and B. Here 2 ohm is available, 5 ohm, 30 ohm, 4 ohm, 10 ohm, 20 ohm. Very simple. Directly we can apply the Wheatstone bridge here. Here we can write in solution. In solution, directly we write 2 into 10 equal to 4 into 5. That means the bridge is balanced. The bridge is balanced and no current is flowing in 30 ohm resistance. 30 ohm resistance means it behaves as open circuit. Now we redraw the circuit. We just remove the 30 ohm resistance. We get this type of circuit. A, B, here 2 ohm, 5 ohm, 4 ohm, 10 ohm, 20 ohm. Now this 2 ohm and 5 ohm connected in series. Let here I1 current is flowing. Same I1 current is flowing in 5 ohm resistance. Then what we get? Here I2 current is flowing. Same I2 current is flowing. Here I3 current. That means this 2 and 5 connected in series, 4 and 10 connected in series. What we get here? We get this type of circuit. Series connection means 2 plus 5 equal to 7 ohm. That is 7 ohm. 14 ohm. 20 ohm. Here just we write 2 ohm and 5 ohm connected in series. Another is 4 ohm and 10 ohm also connected in series. Then what we get is the terminal A and B. Now we calculate the equivalent resistance. What is the equivalent resistance? All are connected in parallel. That means we apply the conventional method. 1 by R equivalent is equal to 1 by 7 plus 1 by 14 plus 1 by 20. We get the value that is equal to, implies that R equivalent is equal to, using calculator, R equivalent is equal to 3.78 ohm. In this way, we solve the Wheatstone bridge principle. If the bridge is not balanced, then what we will do? We apply the star delta conversion. If you like my video, then you subscribe my channel and press the bell icon so that you will find the new video or upcoming video. Thank you.